Hello my dear friends, welcome to all of you. Myself Dattu Patel, assistant professor from LJIT. Earlier lecture we are already discussed about the shortcut case to finding the particular integral which has case 4. Today's session we are discuss about the case 5 to finding the particular integration. Let's move to direct method of obtaining particular integral by case 5 where q of x equal to x into v, where v is a function of x. See, whenever our q of x which is x into v of x, then finding the particular integral 1 upon f of d into x v of x equal to x comes out, then x 1 upon f of d into v of x minus derivative of that term, that is f dash of d upon f of d whole square into v of x. This is the formula to solve the example whenever our q of x which is multiply with x, x into v, means here x sin x, x cos x, x e raised to x, like that. Such kind of example we can use case 5. Let's move on the one example based on the case 5 to find the particular integral. Solve the d square minus 5d plus 6 of y is equal to x into cos 2x. See, such kind of example, our q of x equal to x into cos 2x, that is in terms of product form. Then what we have to do, whenever we finding the general solution, we require the two solution. One is complementary function, second one is particular integral. First we find the complementary function. For that we require the auxiliary equation which is d square minus 5d plus 6 equal to 0. Now factorize that term, then 3 2s are 6, then d minus 3, d minus 2 equal to 0, then factor d equal to 2 and 3, where factors are real and distinct. That is our case 1 of the complementary function. Then yc is equal to c1 e raised to 2x plus c2 e raised to 3x. Now let's move on to the finding the particular integral. Whenever we find the particular integral, we have the formula yp of x equal to 1 upon f of d into q of x, then 1 upon f of d, that is d square minus 5d plus 6, means that term which is indicated by the f of d and is equal to something that is indicated by the q of x. Now substituting the values of f of d and q of x, that is 1 upon d square minus 5d plus 6 into x cos 2x. See, here we apply the case 5 of the shortcut method. Now for that what we have to do, this x will becomes outside into 1, we have the formula x comes outside 1 upon f of d into q of x minus f dash of d upon f of d whole square into q of x. According to that formula, x comes outside 1 upon f of d into cos 2x minus derivative of f of d, that is 2d minus 5 divided by d square minus 5d plus 6 whole square into cos 2x. Now here we, whenever we simplified that term, here we use the case 2 for the shortcut case. Whenever our q of x which is in terms of cos or sinusoidal function, at that case we replace d square equal to minus a square. Here values of a is equal to 2, then d square which is replaced as a minus 2 square minus 5d plus 6, here minus 2 square minus 5d plus 6 whole square, remaining term kept as it is. Now simplified that term, that will give you x 1 upon 2 minus 5d cos 2x minus 2d minus 5 upon 2 minus 5d whole square cos 2x. See, here in denominator portion 2 minus 5d, then here we require the d square term. For that what we have to do, obviously taking the conjugate. For that multiply and divide with 2 plus 5d in first term and simplify that term. In second case, denominator portion has a 2 minus 5d whole square in second term, then we expand the second term. Here in first term a minus b, a plus b, simplified that term, and second term just expanding the brackets, and we get x 2 plus 5d upon 4 minus 25d square cos 2x minus 2d minus 5 upon 4 minus 20d plus 25d square cos 2x. See, here again we apply the second case to finding the particular integral, which has replaced d square is equal to minus a square. Here values of a is equal to 2. Then here replace the d square as a minus a square. Then 25 into 4 minus 4, that is minus 100. Minus 100 plus 4, that is minus 96. Then minus 96 minus 20d cos 2x. Here again replace values of a is equal to 2. Then a square is equal to this term becomes minus 4. 25 into minus 4, that is 100 minus minus plus, then 100 plus 4, that is 104. Now x by 104 kept as it is, this term as a twice cos 2x plus 5d, this one is an operator, then we can written as a d by dx, single times d, then one time derivative d square, then two times derivative d cube, then three times derivative, and so on. Plus here we require the d square term. Denominator portion has a 5d plus 24. Then we require the d square term for the simplification. For that, what we have to do? Taking conjugate in second term. For that, multiply and divide with 5d minus 24. Then in second term, we taking the conjugate and simplified that term. See, in first term, x by 104 kept as it is, twice cos 2x plus 5 derivative of cos, that is minus sin 2x, then minus sin 2x into 2, then 5 2s are 10, it becomes minus 10 sin 2x. Now first term which is kept as it is, and 2 will be common out from the first term and simplified the first term. Then it becomes x by 52 cos 2x minus 5 sin 2x. Now we require the simplification in only second term. Whenever we taking the conjugate in second term, then it becomes 2d minus 5 into 5d minus 24. Just expanding this two product term. Then we get 10d square minus 73d plus 120. In denominator portion, for which is constant a plus b, a minus b, that is 25d square minus 24 square. 24 square which is 576 into cos 2x. Now here again apply the case to d square equal to minus a square. Then here replace d square as a minus 4. Then 25 into minus 4, that is minus 100. Then minus 100 minus 75. Now first term which is kept as it is, we need to simplify it in only second term. Let's move on to simplify the second term. See, first term which is kept as it is, x by 52 cos 2x minus 5 sin 2x plus second term which is 10d square minus 73d plus 120 divided by 4 minus 100 minus 576 cos 2x. Addition of that term and multiply with 4, that will give you, minus sign will be common out, then minus 1 upon 2704 minus d square, that means 2 times derivative of cos, then 2 times derivative, cos as a derivative, single time derivative, sin again derivative, that is becomes cos, and cos 2x into 2 means 10 into 4, that is minus 40, because derivative of cos, that is minus sign, that's why here minus sign will be taken, plus here minus 73 into derivative of cos, that is minus sign, minus minus plus into 2, then 73 into 2, that is 146 sin 2x plus 120 cos 2x, which is kept as it is. This one is our yp of x. Now you know very well what is the general solution. General solution is nothing but the combination of the complementary function and particular integral. Then y of x equal to cf plus pi. You all are aware about the values of cf, which is c1 e raised to 2x plus c2 e raised to 3x plus x by 52 cos 2x minus 5 sin 2x minus 1 upon 2704 minus 40 cos 2x plus 146 sin 2x plus 120 cos 2x, which is our pi. See, in such kind of particular example, first we apply the case 5 of particular integral. Inside this example, we can apply the case 2, case 1, case 3, etc. That is the combination of case 1, 2, 3, 4, 5, any shortcut method. Let's move on the one more example for the better understanding. See, example number 2. Solve the d square plus 2d plus 1 of y is equal to x e raised to minus x into cos x. See here our q of x, which is x e raised to minus x into cos x, means here three term as a product form: exponential function, polynomials of x, and sinusoidal function. See, in such kind of example, what we have to do? Firstly, find the complementary function, then after we find the particular integral. In particular integral, first we apply the case 4 of the shortcut method, then after we apply the case 5, then after we solve by the case 2. See, let's move on the first find the complementary function. Then auxiliary equation is m square plus 2m plus 1 equal to 0. Here a square plus 2ab plus b square, then it becomes m plus 1 whole square equal to 0. Then values of m is equal to minus 1 minus 1. Then factors are real and repeated. Then which case applicable? Obviously case 2, factors are real and repeated to finding the complementary function, or we can say that it is CF. Then C1 plus C2x e raised to minus x. That is our equation number 1. Let's move on to finding the particular integral. Obviously we have the formula 1 upon f of d into q of x. Just substituting these values of f of d and q of x, then d square plus 2d plus 1 into x e raised to minus x into cos x. See, first we apply the case 5, then yp has a 1 upon d square plus 2d plus 1 x e raised to minus x into cos x, then e raised to minus x, which is comes outside. Here we apply the first case 4. Then according to this case, replace d as a d minus 1 whole square plus twice d minus 1 plus 1, then x into cos x. Now simplified that term, then e raised to minus x, here just expanding these brackets, then d square minus 2d plus 1 plus 2d minus 2 plus 1. Obviously minus 2d plus 2d cancel out, 1 plus 1 2, 2 minus 2 will be cancel out. Here x into cos x. Then remaining term e raised to minus x 1 upon d square x into cos x. See here x into cos x, then we apply the case 5. Then according to the case 5, what we have to do? Obviously x comes out because we have the formula 1 upon f of d into x into v is equal to, x comes out 1 upon f of d into v, where v is a function of x, minus f of d whole square in numerator portion, that is f dash of t into v of x. For that e raised to x will be kept as it is. X comes out 1 upon d square into cos x minus d square whole square in numerator portion derivative of d, that is 2d into cos x. See, here we apply the case 5 as a formula. Now we just apply the case 4. Then according to the case 4, here values of a is equal to 1, then d square is equal to minus a square. According to the case 2, we replace d square equal to minus a square, then e raised to minus x, x kept as it is, d square is equal to minus a square, then minus 1 square into cos x, minus 2d kept as it is, d square is equal to minus a square whole square into cos x. Now just simplified that term, and e raised to minus x minus x cos x minus 2d minus 1 whole square 1 into cos x. In denominator portion we can also apply direct 2 times integration. Here multi-product form has a d, then that is the d by dx of cos x. Then our yp of x becomes e raised to minus x cos x, derivative of cos, obviously minus sign, then minus minus plus. Now general solution is y of x equal to yc plus yp, that is our equation number 2. Substituting the values of yc and yp in this equation, yc which is c1 plus c2x e raised to minus x, yp which is e raised to minus x cos x plus 2 sin x. That is our general solution. That is the combination of complementary function and particular integral. Let's move on the one more example. You can try yourself. See this example, d square minus 2d plus 1 of y is equal to x e raised to plus x into cos x, here 2x. You can also solve the example d square plus 1 of y is equal to x sin 2x. This both the example you can try yourself. This example you can also try yourself as a homework. Solve d square minus 1 of y is equal to x e raised to x. See, in this example you can apply case 4 or case 5. Any case you can consider. Both the cases, whenever you get the simplified, answer must be same. Means general solution we can find the any case 4, case 5, as well as you can use the method of undetermined coefficient, as well as you can use the method of variation parameter. Each and every case final answer general solution must be same. You can any method. Understood? I hope you guys you learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. Thank you so much for watching me. If you have any queries regarding this, then feel free contact me. Thank you so much for watching me.